I'm not sure. I'm afraid we need to use math.
Hi, my name's Dr YuHu! Do you want to find something that's not really there, like Tim Tebow's football career? Well, then you need limits. Limits are simply your intended position when you are approaching something. Here are some various properties that can help you in your daily life. Some of these include the sum and difference rule, where you can add and subtract limits like numbers. Also, the product and quotient rule. These let you multiply and divide limits, just like you multiply and divide numbers. Now, the trickiest rule is the constant multiple rule. This tells us that a limit of a constant times a function is the constant times a limit of a function.
Okay, that's actually really complicated. It's just a rule that lets you pull a constant from inside a limit to outside the limit.
You know what? Shut up, Chris! Now, don't take my word for it. Here are some people I've helped to break past the limits of their daily lives.
Dr YuHu changed my life with limits. By using the average rate of change, I was able to determine my car's average speed by dividing the distance I traveled by the time I wasted trying to figure this out. When I wanted to find my instantaneous speed, I just looked down at my speedometer. That's just the slope, the speed that I was going at that point in time. I also could have found my instantaneous velocity using this equation.
Using limits, I'm able to find my own limits. Dr. YuHu also sent me a graph to show me the behavior of limits involving infinity. I also learned all about end behavior, or the way a graph looks at each end.
Haha, thanks guys. Well, anyway, one-sided limits show you the intended position of an object if it comes from the left side or the right side. Two-sided limits show you the intended position of an object coming from both sides. You following me, camera guy? If you buy limits, you also get the sandwich theorem. While this may sound delicious, it's not. It tells you that even if a function does not exist, it proves that the limit does.
So you want to know about the squeeze theorem? I'm going to give you an analogy. Let's say we have three nice people, three lovely ladies, Sally, Susan, and Janet. They always eat different amounts, so you can think of them like a function, kind of like greater or less than. But Sally always eats the most. He always eats more than Susan. And Janet always eats less than Susan. Always. So one day they sit down to have a snack, and Sally has a 300-calorie snack, and Janet has a 300-calorie snack. Well, we don't know how much Susan has, but she's squeezed between the greater function of Sally and the lower function of Janet. Susan is squeezed to have to eat 300 calories, and that's the squeeze theorem.
Thanks to Dr. YuHu, I was able to do things with continuity. A function is continuous if the limit exists where the function exists, also called continuity of point. For every x value has a y value. A discontinuous function is simply where a function is not continuous, or you have to pick up your pencil to draw the graph. Examples of discontinuous functions are a jump function. I have a graph for this, where a function continues on and then jumps to another point in the graph and continues on. The next type of discontinuous function is an infinite discontinuity. Infinite discontinuity is where the graph continues on forever and there is no x value, or x equals 0 on the graph. As you see, the graph does not go through or any point x equals 0 on the y-axis, and it just continues on forever. The next type is called oscillating. Now, the formal definition for oscillating discontinuity is it quantifies the amount that a sequence or a function tends to move between extremes. Now, forget that definition, and instead, look at this. I have a chart for this. Richie, where's my chart?
Here, master.
Alright. This is oscillating discontinuity. This also looks extremely confusing, but it's really confusing. Okay, for continuous functions, there is a theory called extreme value theorem. It is a theory that a value will always have a min and max value on a closed interval, Just like in a football game, you always have your best and worst play. I like to think of it. For continuous functions, there is a theory called the intermediate value theorem. A function on a closed interval takes on every value between a and b, just like how a human takes on every role during their lifetime, such as a child, a husband, a father, a grandfather, etc. A graph of intermediate value theorem is this. The function will always take on every role as it continues through. Thank you, Dr. YuHu, for my help with continuity and discontinuity functions.